Hello, how's it going? In today's video, we are going to make the graphics pipeline for our Python engine. Now, there's going to be a lot of coding in this video, a lot of individual parts, and for that reason, it's helpful if you have already seen the previous video in this series where we took a zoomed out big picture view of the graphics pipeline. So it's definitely recommended. But if you've seen that, let's get into it. Just to start with, in the shader section, we have this function here which basically reads the code, but we don't have any function which compiles the code, so let's add one of those. Okay, so hopefully all things we've seen before. We read the shader code, we pass it into a create info structure, and then we pass that into a creation function. Okay, now we'll use that in a second. So let's pop back and we'll make a new file called pipeline. And pipeline is going to have the creation functions here. So we'll just import everything. And we're also going to use the shaders. Okay, now we're going to need to pass some info into and out of the functions. Now we could do this with lists of arguments. Okay, fair enough. I'm going to go with classes. And there's really no reason to do it one way or the other. It's for variety. So I'll have a class called input bundle and output bundle. Okay, so what are we going to take in and what are we going to put out? Well, we're definitely going to need to take a device to create a pipeline because the device is used to run all of the creation functions. Then we're going to need to know a few other things. We're going to need to know the format of the swap chain, the pixel format of the screen. So we're going to take that image format in. We're going to need to know the screen size, so the swap chain extent. And we're also going to need to specify file paths to the vertex and fragment shaders. So let's create our constructor here to hold the data. Okay, cool. Now, what are we going to put out? Well, when we create the pipeline, we're obviously going to return a pipeline, but there are other sort of side resources which get created at the same time, namely the pipeline layout and the render pass. Okay, now with that out of the way, I'm actually going to create those helper functions before I create the full pipeline initialization. Let's just do the little helper functions because they're a little bit shorter. First of all, we will create the render pass. We're going to need a device and the image format. Okay, so just like I said in the previous video in this series, a render pass is sort of a description of the various resources which are attached to a full run of the pipeline, including all the subpasses. Okay, that didn't take long. So just as I described in the video before, we specify what we want to happen to the color attachment when we ready it up, ready to go. And do we want to store things when we write the pixels? Well, of course we do. And do we want any side effects to be performed on the stencil buffer? No, in this case. As well as the image layouts that we're going to use. Okay, now we'll make a color attachment reference. Now, the analogy here is kind of like an OpenGL, where you create a texture for a color buffer and you define all the operations, and then you bind it and say this is color attachment number 0. This is a similar thing that we're doing here. Okay, with all of this defined, we can then create a subpass. And then we can finally start specifying the render pass. So then we go ahead and create it. As always, remember this random none that hangs around is the memory allocator. We're not using a memory allocator, we're just going to use the default allocator, so we'll just say none. Alright, so we have that. The next step is to create a pipeline layout. Now, from the previous video, remember, a pipeline layout describes which, if any, push constants and descriptor set layouts, will be used with a given pipeline. In our example at the moment, we're setting both of those to 0. We're not taking any uniform data, but we still have to create a pipeline layout. Okay, great. Now let's get to the actual work of making the pipeline. And this is quite a big function, so we're going to break it down into steps. Okay, the first step is vertex input. In other words, how are we going to take input into the pipeline? What sorts of bindings and attributes and everything do we have? Okay, that was simple enough. It's pretty simple at this stage. Okay, the next part is the vertex shader. Okay, so as I was saying earlier, this is pretty much what we expect. We specify which stage we're creating, where the compiled code is, and the entry point. Right, so then we have input assembly. In other words, topology. What sort of topology of shapes are we creating? We're going to go triangle lists because that's how we make triangles. Then we're going to have the viewport and scissor. And for these, we essentially want to just cover the whole screen. So we want to start at 0, 0 and cover the full extent of the swap chain. Okay, we then use the viewport and scissor info to create what's called a viewport state. Okay, good. So with that done, we then have the rasterizer. Remember, the rasterizer is in charge of interpolating attributes between vertices to fill in the shapes, essentially. Okay, so some of these are a little funky. Depth clamp is basically saying if the depth of a pixel falls outside the acceptable range of 0 to 1, should we keep it but simply clamp the depth? We don't want that to happen. We want those pixels to be discarded. And rasterizer discard is a weird option which essentially just disables the whole pipeline and stops it from outputting fragments from the rasterizer. A little bit funky, but yeah, we're not going to do that, clearly. And then we just specify the backface culling configuration, and that's the rasterizer. So as you can see, absolutely a lot of steps here, a lot of individual bits. Next up, we have multi-sampling. Great, so we're essentially doing no multi-sampling, but we still do need to specify that, and this is equivalent to just sampling with one count. Okay, next up, we're going to create the fragment shader, and for this we can grab the vertex shader that we did up above and replicate that. Okay, so now that the fragment and vertex, vertex and fragment shader modules are being created, we can bundle them together into a list. Okay, on with the next stage, which is color blending. So this is essentially alpha blending, if it's applicable. Right, okay, so we've set this up, and then we use that in the in making the color blending. So we're almost done. We've got the basic stages of the pipeline prepared. Now we just need to create the side resources, that's the layout and the render pass, and then tie everything all together and create it. Okay, so hopefully you can see here that really this is kind of just using the same info that we've already sort of configured above. So nothing new here, just tying it all together. We then take this info and use it to create the graphics pipeline. Okay, so there we have it. Just note that this is called create pipelines, not create pipelines. So, also this VK null handle. So this Vulkan null handle is expected for, it's in place of the pipeline cache. So it's possible to create what's called a pipeline cache. It's a sort of a base class where you sort of save info about a pipeline so you can recreate pipelines on the fly more quickly. We're not going to do that here. But anyway, this actually returns sort of a list or some sort of iterable object. So we want to pick the first one there because only one will be created. So we've created everything. We need to destroy the shader modules that we created before. There we have it, and then finally we can return our result. Awesome. It's looking pretty good. So we'll go to our engine. So go to main, and we will actually use this. So we'll go ahead and import that class. And what we have here, we'll go self make pipeline. Okay, so it should be fairly straightforward at this point. We set up an input bundle, we pass that in, gives us an output bundle, then we read from the output bundle. Just double check this, so we can go over here. Shaders, and it's vert.spv and frag.spv. Okay, so the Vertex file path. Fingers crossed. It'll give us an error if that's wrong anyway. So then we go, okay, get an output bundle. What? Come on. Sometimes linting and autocomplete is not good. Just do that, okay? Can you not autocomplete for once? Okay, then we want to read the info out from that. So we've got three things: pipeline layout, render pass, and the pipeline itself. Okay, so testing time. Let's run this. Okay, seems to go just fine. Now we have the standard sort of error codes at the bottom saying, hey, you've made these things, but you haven't destroyed them. Yep, that makes sense. So we will just go down to the close function, and right up here, we'll destroy them. Okay, let's give that another go. We make it, and yep, we go through all of this, no errors, it is done. Excellent, cool. Okay, so yeah, again, pretty long session, a lot of coding, a lot of little steps, but it adds together to give us a graphics pipeline. Yeah, anyway, I hope you enjoyed this, and I will see you again soon. Bye.